Hi everyone, in this video I will be telling you how to calculate and make accurate low capacitance pulsar probes. Making them yourself will allow you save a minimum of $80 when you don't buy them from a specialty shop. Well, you can order them from me on eBay. I'll leave a link. I took a look at this shop. As you can see here, samples with similar characteristics are more expensive. I made such a table to compare the advantages and disadvantages. I will leave in the archive under the video. On the left are my samples, on the right are the most similar ones. In addition to the price advantage, we have an advantage in usability. Unlike the old probes, we have more modern spring-loaded contact needles. In addition, the probes are easy to install in cheap, flexible arms made in China. This offers advantages in ease of use and positioning accuracy. All calculations in this video are based on information from a video on the Radio Dinosaur channel. I will leave a link to the channel. This is the equivalent circuit of the oscilloscope probes connected to the circuit to be measured and to the oscilloscope. On the left, G1 stands for the signal source. On the right is the equivalent circuit of the oscilloscope with internal resistance R OSC and capacitance C OSC. These values are taken from the oscilloscope documentation. If you have different values, you can recalculate them for your case. All formulas are listed in this file. In the middle, between these blocks, are what we need to make. CRG174 is the capacitance of the cable. Here is how I calculate it. We refine the element ratings depending on our connection conditions. The results are entered into our circuit diagram. As a result of this, we got this circuit. This is the circuit that we will make. Here I have given the methodology for calculating the capacitor from the printed circuit board. Of course, it was possible to buy a factory condensator at 5 picofarad, but I went on the way to achieve accuracy, so we will make the calculations and later translate it into reality in the production of printed circuit board. After performing all calculations, we got the area of the capacitor of the required capacitance on the printed circuit board. As a result, it has such a calculated input capacitance and resistance. Later, we will measure these values. To make the pulsar probe, we will need a flexible coaxial cable. I use RG174 with a length of 24 cm. In these probes, the cable should be much shorter than the wavelengths. I plan to measure frequencies below 100 MHz. A BNC connector to connect to an oscilloscope. The connector is compatible with my RG174 cable. Resistor according to the calculated 820 and 100 kΩ. Detection needle P50B1. They are used to connect the oscilloscope probe to the circuit to be measured. These needles are very thin and spring-loaded, should be easy to connect to small contact pads. To make a capacitor from glass textilite, calculated capacitance in my case 5.33 picofarad, I ordered it on GLC PCB, Gerber file and schematic in the archive on the link in the description. We'll need an enclosure to the signal probe and ground probe. The enclosure is made so that it can be easily attached to such a flexible arm. I bought this with the bank tool table. The model of the enclosure was made in Compass 3D. The model of the enclosure is also in the archive on the link. I measure the capacitance with an oscilloscope connected. For the measurement, I connect the pulsaclue with detector needles to the nano-VNA. The probe is already connected to the oscilloscope at the other end. Such measurements are the most objective because the probe is connected to the measured circuit in the same way. I switch on the probe and measure the supply voltage, for example at the choke or at the chip input after the stabilizer. After setting the correct settings on the nano-VNA, the device shows the reactive impedance. Measurements with this device have a number of disadvantages. In general, it is designed for other tasks, not for measuring capacitance. As it is known, reactive resistance includes two components, inductive and capacitive. We could calculate the capacitive component accurately if we knew the inductive component, but judging from the fact that the instrument shows a negative number, the capacitive component has a much higher value than the inductive component. Let's assume that the inductive component is 0, then the capacitance will be calculated using this formula. I added the calculations to the table for different frequencies and got the values of capacitance. I want to note that because we did not take into account the inductive component when calculating the capacitance, the obtained figure is always greater than the real one. That is, the real capacitance of the probes is somewhere in the middle between the calculated and measured capacitance. A low capacitance probe is needed to make minimal changes to the circuit being measured. This is especially noticeable in sensitive circuits like this one with a quartz resonator. Connecting a probe introduced capacitance that can disturb the resonance conditions. This is why a low capacitance probe is used. The file shows the total cost including shipping, not including walk-in. Also in the file are links to shops where I bought parts. If you do not want to make them yourself, you can buy them from me on eBay for $27. This price is much lower than the market price. This will help the development on the channel. I did not manage to make 3 picofarad probe like the author of the Radio Dinosaur channel, but I consider 7 picofarad to be a low of capacitance compared to the capacitance of the standard probes that came with the oscilloscope. As we have seen today, there is nothing complicated in making quite accurate device at home. That's all for today. Subscribe to the channel, turn on notification. Thanks for watching. Bye everyone.